Hello. This video is going to be on section lesson 1-1, one variable equations. This is the do now that we covered for today, and we're just going to quickly go over this. Now, the variable is always going to be represented by a lowercase letter. So in this case, our variable is x. The expression is going to be x plus 5. Notice that the expression does not include the equal sign. And finally, the equation is going to be the whole x plus 5 equals 10. Okay, so for the second part of the do now, I have you solve for x. Now this is pretty basic stuff, but there's something very important that we should note. There's a very important rule that I had the class write down, and this is what it is. So when variables in a term have only coefficients, you can add or subtract the terms so that the variables are on the same side. And I would like to note that I'm talking about equations. When I mean by same side, I'm talking about the same side of the equal sign. So let's take a look at this, for example. 4x equals 2x minus 2. First thing I want to do here is point out the different terms. So I have one term here, another term here, and 3 terms in total. Now, the variable that we're talking about here is x. Now, notice that the terms that contain the variables x, they only have coefficients. So here the coefficient is 4, and here the coefficient is 2. So when the variables in the term have only coefficients, that means that I can add or subtract the terms so that the variables are on the same side. So because they only have coefficients and nothing else, I can go ahead and subtract this 2x on both sides. This cancels out, and so what I get is 4x minus 2x. That is going to be 2x is equal to negative 2. So notice what I did. I moved the x to the other side, so now I can solve this like a regular algebra problem. So I divide both sides by 2, and so x is equal to negative 1. So this is actually very basic, but I want to go ahead and look at more complex problems. So here's our rule again. Now, again, let's point out the different terms here. Here is one term, and notice that this term has a variable with only a coefficient. So I can go ahead and add or subtract this to the other side if I wanted to. But notice this 16 right here, I am not allowed to subtract 16 to move it to the other side right away. That is not allowed because this 16x plus 2 is the numerator, and then 5 is the denominator. So this whole thing is actually one single term. And notice that since in this term we have our variable x, it has a coefficient of 16, but you also have plus 2 divided by 5. So why the reason we can't subtract 16 is because the term does not have only a coefficient. So in order to solve this one, what we need to do is get rid of the fraction first. So what we can do is multiply both sides by 5. And so this 5 is on top, this 5 is on the bottom. They cancel out. And what we have here is 5 times 4x. So we're going to multiply 5 times 4, which is 20, and then we still have x is equal to 16x plus 2. Now I can go ahead and look at this rule again and notice that I have 3 terms now, and this term has a variable x with the only thing next to it is a coefficient. So now I can go ahead and add or subtract. In this case, I'm going to subtract 16 from both sides, so I can combine the variables together. So 20x minus 16x, I'm going to subtract that, and so that gives me 4x is equal to, this cancels out, and all I have left on the right hand side is 2. I'm going to go ahead and divide both sides by 4, and finally my answer is x equals 1/2. Okay, so we're definitely going to see the use of this rule in the future, so it's very important to point it out right now and remind you as we go along throughout the year. Okay, so what we started in this class today, this is August 29th, a Monday. We started with page 3, and the learning targets are to create an equation in one variable from a real world context and to solve an equation in one variable. So here is an equation in one variable where we solved for x and we got x equals 1/2, and here is another equation in one variable where our only variable is x. Now, one thing that I really like to highlight is understanding what's going on. And when you're reading a text from a mathematics textbook, you really have to scrutinize all the things, all the details in order to understand the problem. And once you understand the problem, you're able to answer the question correctly. So the reason I have this picture is to just make you analyze and think about what's going on. So I asked the question, what's wrong with this picture? Well, this astronaut is standing on the moon, but there is a moon in the background. Does that make sense? Nope. Does not make any sense at all. So it's important to look at what you are studying and analyze it and make reasonable conclusions. So always ask yourself what's going on. So whenever you're reading a paragraph, whenever you are answering a question, you want to know all the details that you have. So always ask yourself what is going on. Alright, so as we read this paragraph, keep in mind, look at all the details, immerse yourself into the question. That way you don't miss anything and you're able to answer the question correctly. Alright, so a new water park called Sapphire Island is about to have its official grand opening. The staff is putting up signs to provide information to customers before the park opens to the general public. As you read the following scenario, mark the text to identify key information and parts of sentences that help you make meaning from the text. Alright, the Penguin, one of the park's tube rides, has 2 water slides that share a single line of riders. The table presents information about the number of riders and tubes that can use each slide. Alright, so take a look at this table. Notice we have 2 slides. one slide seems to only take 2 writers at a time. The other slide takes only 4, and the slide with just 2 writers takes only 0.75 minutes. The slide with 4 writers takes 1.25 minutes. Continuing on, Jabir places a sign in the waiting line for the penguin, which is the name of the slide. When a writer reaches the sign, there will be approximately 100 people in front of him or her waiting for either slide. The sign states, from this point, your wait time is approximately blank minutes. Jabir needs to determine the number of minutes to write on the sign. Work with a partner or with your group on items 1 through 7. Okay, so mainly you get a lot of text here, and you are left with your own imagination to visualize what is going on here. But you are lucky because I do have a visualization here, and here is the entrance of the ride called the Penguin, and here is the line of people. Now, looking back at the text, it says that there are 100 people in front of Jabir waiting in line. So Jabir is somewhere around here, and he counts 100 people waiting in line. Also, looking at the table, slide 1 contains only 2 people, and the length of time it takes for it to go down is 0.75 minutes. Slide 2 carries 4 people at a time, and the time it takes for it to go down the slide is 1.25 minutes. So Jabir is here, and he's putting a sign right after the 100th person that says, from this point your wait time is approximately blank minutes. Jabir has to use mathematics in order to figure out how much time he has to wait. Alright, so let's take a look at the first question. Number 1. Let the variable r represent the number of writers taking slide 1. Write an algebraic expression for the number of tubes this many writers will need, assuming each tube is full. So what I have here in red are some guiding questions that will help you lead you to the correct answer. So first of all, what does r equal? Well, r represents the number of writers taking slide 1. Now we want to write an expression. Remember, an expression from the beginning does not have an equal sign. For the number of tubes, we want to know how many tubes are going to be needed for slide 1. So let me just go ahead, take a look back here. Slide 1, there's 100 people in total. Now, out of those 100 people, we have a certain number of people going to slide 1. So either those 100 people go to slide 1 or they go to slide 2. Now, the text says that our number of people are going to slide 1. So in order to r equals the number of people in slide 1. It's asking for the number of tubes. Well, let me ask you this. Instead of having a variable, let me ask you, what if there were 10 people taking slide 1? So there's 10 people taking slide 1. How many tubes do you need for those 10 people to go down slide 1? Well, remember, slide 1 has a tube that can hold a maximum of 2 people. So if each tube holds a maximum of 2 people, I basically have to take 10 divided by 2, and that's going to give me the number of tubes that I need. So 10 divided by 2, that gives me 5 tubes that I need. So now this is the key here. Instead of saying 10 people, what the book is telling me is that I have R people taking slide 1. So if I divide it by 2, that's going to give me the expression for the number of tubes that I need. So R over 2 equals the number of tubes needed for slide 1. There we go. Alright. Let's go ahead and take a look at number 2. Next, write an expression for the time in minutes it will take the riders to go down slide 1. Okay, let's use my example of 10 riders, and we needed to find the number of tubes, and we found that we needed 5 tubes for those 10 riders. Now, if we have 5 tubes going down the slide, remember from our chart, it takes 0.75 minutes for each tube to go down the slide. So all we have to do is take the number of tubes and multiply it by the time it takes a single tube to go down, and that's going to give me the total time for all those tubes to go down. So again, since we figured this out, instead of having 10 over 2, what we really have in terms of our problem is R over 2, which again, the number of tubes needed for slide 1, and we basically multiply it by 0.75, and that is going to give us the total time for the tubes to go down slide 1. There we go. Number 3, assuming that our riders take slide 1 and that there are 100 riders in all, write an expression for the number of riders who will take slide 2. Okay, there's 100 people in line. They either go to slide 1 or slide 2. There are R riders specifically going to slide 1. So how do I figure out how many are going to slide 2? Well, you just basically take 100, and if you subtract R, what are you left with? Well, you're left with the number of people who are taking slide 2. So 100 minus R is equal to the number of people taking slide 2. Number 4, using the expression you wrote in item 3, write an expression for the number of tubes the riders taking slide 2 will need, assuming each tube is full. This is basically the same thing we did for number 1. We took our number of people and divided by the number of people a tube holds, which is 2, and that gives us the number of tubes for slide 1. Now for slide 2, we're going to take the number of people in slide 2, which is 100 minus R, and divide it by the number of people a single tube can hold, which in this case is 4 people. And this is basically the expression that we need. 5, write an expression for the time in minutes needed for the riders taking slide 2 to go down the slide. Well, this is what we did. What we did for question number 2 is basically the same thing that we need to do here to get now question number 5. We take the number of tubes. So this is the number of tubes in slide going through slide 2. So we take 100 minus R divided by 4, and all we do is multiply the time it takes for a single tube to go down slide 2, which is 1.25. There we go. Number 6, since Jabir wants to know how long it takes for 100 riders to complete the ride when both slides are in use, the total time for the writers taking slide 1 should equal the total time for the writers taking slide 2. Write an equation that sets your expression from item 2 equal to the expression from item 5. So the answer that we came up for item 2 was r over 2 times 0.75 is equal to the expression from item 5, which was 100 minus r over 4 times 1.25. Number 7, solve your equation from item 6. Describe each step to justify your solution. Alright, so we're going to write this again. R over 2 times 0.75 is equal to 100 minus r over 4 times 1.25. Okay, so we need to solve for r. Now this is why I pointed out the very first thing that we did, one of the very first things that we did was to solve for x. We're following, so this is the basic idea that we went through in order to solve this, using this key idea. We're going to use it, same idea, we're going to use it to solve this expression. So instead of solving for x, we're solving for r. And here is the idea. Now we want to go ahead and move the r so that they are both on the same side. And once they are both on the same side, we can combine like terms and then solve for r. But before we can do that, notice that this r, it has a coefficient of -1. So there's an invisible 1 right there, a -1. We cannot add 1 r to both sides just yet because this r is a part of a fraction. It's a part of a fraction. So we basically can put the fraction in parentheses, and then we're multiplying that fraction by 1.25. So before we can move this r to the other side, we have to get rid of what's outside of the fraction. So we're going to follow the same ideas that we learned from the undoing method, or doing reverse PEMDAS. But basically, what you want to do is look for addition or subtraction first. There is none here. You may say, well, we're subtracting inside the parentheses, but notice that parentheses is last. So looking for multiplication or division, we're multiplying by 1.25. So what we need to do is divide, do the exact opposite, which is to divide by 1.25. So whatever you do to one side, you must do to the other. .25. Okay, so this basically 1.25 over 1.25, that becomes 1. And what we have here is r over 2 times 0.75 over 1.25 is equal to 100 minus 1r over 4. Alright, let's go ahead and just grab our calculator here. Let's go ahead and calculate 1.75 divided by 1.25, and that's going to be 0.6. So we have 0.6r over 2 is equal to 100 minus 1r over 4. Alright, So we got rid of everything outside of the fraction, but we still have the fraction to deal with. To get rid of the fraction, we need to take care of this 4 right here. So if we are dividing by 4, the inverse or the opposite of dividing by 4 is to multiply by 4. Now notice when we multiply here by 4, the top 4 cancels out with the bottom 4. And we could take this 4 and multiply by 0.6 r, but notice that we have 4 over 2. Well, what does 4 over 2 simplify to? 4 divided by 2 is just 2. And then we have 0.6 r is equal to 100 minus 1r. Okay, so let's go ahead and multiply this 2 times 0.6, and that is going to be 1.2r is equal to 100 minus 1r. Okay, finally, let's count the terms that we have here. We have one term, 2 terms, 3 terms. Now notice that the terms with the variables r only just have coefficients. So here and here. That means that we can now go ahead and move the terms containing the variables all to one side. So let's go ahead and take this term right here. So to move this negative 1r to the other side, we basically have to do the opposite, which is to add 1r to both sides, plus 1r. This is going to simplify to just 0. And here we have 1.2r plus 1, which is going to be 2.2r equals 100. And finally, we just have a really simple algebra problem. So we divide both sides by 2.2, and our answer is r equals 100 over 2.2. Let's use our handy calculator here. 100 divided by 2.2 is going to be 45.45, and it just keeps on going. If it keeps on going, then this bar on top of it is tells you that it just keeps on going 45, all the way to an endless number of 4 or 5s. Okay, so finally we solved for r. R equals 45.45 and then 45. Now this is what I want you, so I guided you through solving this really complex algebra problem. You're solving for r. Now I want you to interpret what specifically that solution means. I want you to tell me how does r equal 45.45 help us solve our original problem, which is to find out what to put here, the wait time that Jabir must write after that 100th person. So the 101th person is going to need to is going to read the sign to know how much time that person has to wait. So it is up to you to go ahead and interpret what r equals 45.45. Read number 8. Consider the meaning of the solution from item 7. Explain why you should or should not round the value of r to the nearest whole number. How many people out of the 100 writers will take slide 1? Read number 9 as well. Use the expression you wrote in item 2 to determine how long it will take the number of writers from item 8b to go through slide 1. Evaluate the expression for the appropriate value of r. B. How many minutes will it take the writers to go through slide 1? round to the nearest minute. And finally, question 10 is where we can finally find that answer for how long is it going to take to wait for those 100 people. Alright, so here is the assignment. I want you to complete the rest of this. So I want you to do number 8, 9, 10, skip number 11, and then do number 12. So this is how I'm going to grade your first assignment. If you have partially completed, I'll give you 79% or lower. If you complete it up to number 10, the most you can make is a B. If you complete it up to number 12, the most you can make is an A. And if you do it all the way to number 12 and it is fully correct, then you get 100%. Alright, so thank you for watching, and always ask yourself what's going on.